All right, let's talk about security. Today, we're basically tearing up the old playbook. Why? Because in a world where your office can be anywhere, a coffee shop, your kitchen table, you name it, the old rules don't just bend, they completely break. So we're gonna dive into what security looks like now. So I want you to start by thinking about this question. What happens to your security when those walls you used to rely on just vanish? I mean, when your team and your data are literally scattered all over the world, those old rules just don't cut it anymore. For years and years, security was just like building a castle. You'd build a huge wall, dig a deep moat, and then you'd assume everything and everyone inside was safe. But today, well, today looks a lot different. The walls have crumbled. With the cloud and remote work, that whole perimeter is gone, which forces us to start with a totally new, kind of scary assumption. Trust absolutely nothing by default.
And that right there is the core problem we're all facing, the vanishing perimeter. With our data and our people all over the place, that security boundary we used to depend on, it's not a solid wall anymore. It's more like a dotted line somebody drew in the sand.
So if we're all working in the cloud, it kind of begs the question, right? Who's actually responsible for keeping everything safe? And spoiler alert, it is not as simple as just handing the keys over to your cloud provider. This is where we have to get really clear on something called the shared responsibility model. What's so interesting about this chart is how that responsibility shifts. Just look at the column on the far left, on premises. That's the old way. You, the customer, are responsible for absolutely everything, top to bottom. But as you move to the right, from IaaS to PaaS and finally to SaaS, you see the provider starts taking on more and more of the load, from the physical building all the way up the tech stack. But, and this is a huge but, no matter which one of those models you use, you are always responsible for these four things. It's your data, it's your users' identities, it's the security of their laptops and phones, and it's the choices you make when you set the whole thing up. That part never goes away. This quote just sums it up perfectly. You can pay someone else to do the tasks, sure, but you can never, ever delegate the accountability. Think of it like this. The cloud provider locks the doors to the building, but you're still the one responsible for what happens to your stuff inside. Okay, so let's shift gears and talk about the modern philosophy that was built for this new world. If we can't trust the network anymore, we need a whole new game plan. And that plan is called the Zero Trust model. Now, this is a massive change in how we think about security. It's not trust but verify anymore. It's never trust, always verify. Zero Trust starts with the assumption that attackers are already inside your network, so it treats every single request for access, doesn't matter if it's from inside or outside, with total suspicion until it's proven to be safe. This whole strategy is built on three really powerful ideas. First, you verify explicitly. That means you use every piece of information you can get, who the user is, where they are, what device they're using, to prove they are who they say they are. Second, you use least privileged access. Basically, you give people the absolute minimum level of access they need to do their job and nothing more. And third, you assume breach. You build your defenses as if the bad guys are already past the front door. So, if we can't trust the network, what do? We have to make our data defend itself. And that's where cryptography comes in. We build security right into the information itself, making it our very last and hopefully strongest line of defense. Now, there are two main ways we do this. On the one hand, you have symmetric encryption. It uses one single key for locking and unlocking, which makes it super fast and great for encrypting huge files. On the other hand, you have asymmetric encryption, which uses a clever pair of keys, one public, one private. This solves the huge problem of how to share keys securely, and it's the foundation for things we use every single day, like those little lock icons in our web browsers. All right, now let's talk about a related idea, hashing. The best way to think about this is like a one-way digital fingerprint. You can easily turn any piece of data into a unique hash, but it's designed to be practically impossible to go backward. You can't turn the fingerprint back into the person, right? And that's exactly why it's so vital for protecting things like passwords. And to make that password hashing even stronger, we use this really cool technique called salting. Before a password gets hashed, the system adds a unique random piece of data, the salt, to it. This means that even if two people happen to have the exact same password, their stored hashes will look completely different. It just makes them way, way harder for attackers to crack. Look, a modern security strategy isn't about finding that one magic silver bullet. It's about creating multiple overlapping layers of defense. The idea is that if one layer fails, there's another one right behind it ready to stop an attack. We call this defense in depth. This here breaks that whole strategy down into its 7 layers. It starts at the very bottom with physical security. We're talking actual locks on data center doors. And it moves all the way up the stack, through the network, the computers, the apps, and finally to the data itself. Every single layer is another hurdle, another tripwire designed to slow an attacker down and give your security team a fighting chance. So what's the whole point of all these layers? Well, it all comes down to protecting what's known in the industry as the CIA Triad. We want to ensure our data's confidentiality, which means keeping it secret, its integrity, which means keeping it accurate and trustworthy, and its availability, making sure the right people can get to it when they need it. Okay, so for our last section, how do big organizations actually manage all this insane complexity? Well, they use a structured approach, a framework called Governance, Risk, and Compliance, or for short, GRC. GRC really provides the playbook for everything we've talked about. Governance is about setting the rules of the road. Risk management is about finding and prioritizing all the potential threats. And compliance is about making sure the organization is following all the laws and regulations it needs to. And that compliance piece gets especially complicated when you start talking about these 3 concepts. Data residency is simply where your data is physically stored. Data sovereignty is all about whose laws that data has to follow. And data privacy covers how you're required to handle and protect it. Honestly, getting these 3 things right is one of the biggest challenges any global company faces today. So at the end of the day, the really crucial thing to take away is that the modern security playbook has been completely rewritten. The old rules, the old walls, they just don't protect us anymore. Which leaves us with one last kind of provocative question to think about. Is your security strategy still defending a castle that doesn't even exist anymore? Or is it truly built for the cloud?
All right, welcome. Today we are diving into a high-speed masterclass designed for anyone, and I mean anyone who's tackling the Microsoft SC900 exam. We're going to cut right through all the noise and lock in on the core concepts you absolutely have to know to pass this thing.
So, you're gearing up for the SC900? You are in the right place. Just think of the next few minutes as your ultimate focused study session. We're going to break down all the essentials, one by one, to really build up that exam day confidence. Okay, let's get into it.
So here's our game plan. We'll kick things off with your role in the cloud, then we'll build a digital fortress, get into that zero-trust mindset, talk secrets and keys with encryption, navigate the rules of compliance, and then wrap it all up with a final cheat sheet. Let's do this.
First up, the shared responsibility model. Now, this is a huge concept on the exam, and it really all boils down to one simple question. When you're in the cloud, who is responsible for what? Trust me, getting this right is absolutely crucial.
You know, the easiest way I found to remember this is the apartment analogy. It just works. Your cloud provider, like Microsoft, they're the landlord. They're in charge of the physical building. You know, the data centers, the servers, the big network pipes. But you're the tenant. You are responsible for everything inside your apartment and, most importantly, for locking your own front door.
Now, this is where it gets really interesting, because you can see how that responsibility shifts. With IaaS, that's infrastructure as a service, you manage the most. Basically everything from the operating system up. Then you move over to PaaS, platform as a service, and the provider starts to take on more, like the OS. And then with SaaS, software as a service, think Microsoft 365, the provider manages almost the whole shebang. But look closely. See that blue bar for the customer? It never fully disappears. You're never completely off the hook.
And that brings us to the most critical exam tip right here. No matter what service model you're using, IaaS, PaaS, or SaaS, you, the customer, are always responsible for these 4 things. Your data, the identities and access of your users, the endpoints, you know, the laptops and phones connecting to your services, and of course the configuration choices you make. Burn this into your brain.
Okay, let's move on. Now we're going to talk about building our digital fortress. We're going to use a strategy called defense in depth. And the idea is actually pretty simple. You never ever rely on just a single wall to protect you. You build layers, lots of layers.
Let's stick with that medieval castle idea for a second. An attacker can't just stroll up and grab the crown jewels, right? No way. They have to get past the moat, the outer wall, the inner wall, the guards. That's defense in depth. And it works the same way here, from the outside in. You start with physical security, that's the actual building. Then identity and access. Who has the keys? You secure the perimeter, then the internal network, then you protect the compute layer, the virtual machines, and the applications running on them. And what's at the very center? The treasure, your data. Each layer slows an attacker down, making it harder and harder to get to the prize.
So, why do we build all these layers? Well, it's to achieve the three main goals of security, which we call the CIA Triad. First, C for confidentiality. That's keeping secrets secret. Then I for integrity, making sure the data is accurate and nobody's messed with it. And finally, A for availability, which just means making sure everything is online and working when you actually need it. Every single security measure you put in place serves one of these three goals.
Okay, so that whole castle and moat idea, it's a great way to understand layers, but it's a bit old school for today's world. I mean, work happens everywhere now, right? So we need a modern strategy, and that's where the zero trust mindset comes in.
This quote, this is the entire philosophy right here. It's a complete 180 from the old way of thinking. Instead of just trusting people because they're inside our network, the new rule is to assume nothing is safe. You verify every single request, every single time. It doesn't matter where it's coming from.
And here's the contrast, plain and simple. The old model, the castle and moat, it had this hard, crunchy outer shell, but a soft, chewy center. Once an attacker got inside, it was pretty much a free-for-all. Zero Trust flips that script. It says the inside is just as dangerous as the outside. Every single request has to prove it's legit every single time.
This entire mindset is built on three core principles you have to know. First, verify explicitly. That means you always authenticate and authorize based on all the data you can get. Who's the user, where are they, what's the health of their device, and so on. Second, use least privileged access. Give people the absolute minimum access they need to do their jobs, and only for as long as they need it. And third, maybe the most important, assume breach. Basically, you design your security as if an attacker is already in your network.
So how do we actually do all this stuff at a technical level? Well, that brings us to the tools of the trade, the things we use to protect the data itself. We're talking about encryption and hashing.
Okay, this slide is super important because people get these two mixed up all the time. Encryption is a two-way street. You use a key to scramble the data, and then you use a key to unscramble it. You can always get the original back. Hashing, on the other hand, is a one-way street. You feed data in, and it spits out a unique fingerprint, a hash, but you can never turn that hash back into the original data. That's why we use it to verify things, like passwords, without actually storing the password itself.
All right, pop quiz. This is exactly the kind of question you'll see on the exam. So, the HR team wants to protect employee data that's being stored. What do they use? Is it A, hashing, B, encryption in transit, or C, encryption at rest? Take a second. Think about it.
And the answer is C, encryption at rest. Why? Because the keyword in the question was stored. Stored data is data at rest. It's sitting on a hard drive, in a database, whatever. In transit would be for data moving across the network, like an email. This distinction is a must-know for the SC900. Okay, let's switch gears a little bit, from the technical stuff to the rules of the road. On the exam, you're definitely going to run into compliance concepts. We're going to focus on two big ones that people often confuse.
First up is data residency. And this one's pretty simple, actually. It's all about geography. It literally just answers the question, in which country or physical data center is my data being stored? That's it. Some regulations require data to physically stay within a country's borders, and that's data residency.
Now, data sovereignty. This one builds on top of residency. It's the legal concept that says your data is subject to the laws of the country where it's physically located. So if your company's in the US, but your data is stored in Germany, that data is subject to German laws. That's a really, really important distinction to understand.
Phew, we have covered a ton of ground. So now, let's boil it all down into the ultimate cheat sheet for your final review. This is that high-density summary you need right before you walk into the exam.
Okay, let's run through this one last time. Shared responsibility. You always own your data and identities. Defense in depth. Layers are your best friend. The CIA Triad, confidentiality, integrity, availability, the three goals of all security. Zero Trust, our new mantra. Trust no one, verify everything. Encryption, that's the two-way process to protect data confidentiality. Hashing, the one-way fingerprint for data integrity. And finally, data sovereignty. Wherever your data sits, it follows the local laws. You got it? Good.
And there you have it.
You now have the framework for success on the SC900. You've got the knowledge, so the only real question left is this. Which of these core principles, whether it's zero trust or least privilege, or just thinking in layers, what's the very first one you're going to apply when you log in tomorrow? Think about it, and good luck on that exam.